Well, hello everybody. Welcome to this amazing free webinar event, the use of VR in training. I'm David Moreno. I'm the Chief Marketing Officer of VRAI. On behalf of the European Training and Simulation Association, we'd like to thank you for joining us today. I guess this is a great topic and you are really interested in knowing how companies and institutions are applying virtual reality for training. I have to give great thanks to Ian and Steve from the European Training and Simulation Association for supporting this event and co-hosted with us, and Holiday Group as our media partner. Thanks, Andy and Holly, for your always welcome support. You, the audience, if you are thinking about being part of this community, you should be part of the ETSA Association. And if you would like to be aware of what's going on in the modern simulation and training industry, you definitely need to look at Holiday Group and the media. So thank you, everybody. Today we have an amazing lineup of panelists, which are Christopher Roche from GE Hitachi Nuclear Energy, David Ripert, that will join us in the live Q&A at the end of this, after all these sessions, and then Niall Champion from the VRAI company, and then Professor Bob Stone from the University of Birmingham. So officially welcome. Thanks, GE Hitachi Nuclear Energy, VRAI, and the Human Interface Technologies team, and ETSA and Holiday Group for supporting this webinar. This is the agenda for today. So I'm doing the opening and the brief intro. I will do a short introduction as well about why we truly believe that virtual reality is becoming the standard for training across industries. I guess that's why you also attended this webinar today. Then Christopher will step up and talk to us about what GE Hitachi is doing in regards to virtual reality for training. Then Niall will talk about from fighter pilot to the factory floor, virtual reality and the potential to democratize simulation training. Finally, Professor Bob Stone, an eminence here, he's been here for a long time in the massive ecosystem. So he will share with us, well, behind this topic, avoiding the risk of technology push, human factors for effective exploitation of ETSA and defense training. And finally, we'll have a live Q&A panel, adding David Ripert, as I mentioned before, from the VRAI Association. You can drop your questions on the chat. You also have a special button for questions and answers. You can drop them there. I will try to write them down. And at the end, the live Q&A, I will drop some of general questions for discussion, but I will try to drop some of yours to different panelists. So let me start by sharing with you some news from big institutions, big companies that, well, they're going to invest, and they are betting in virtual reality as the technology for training. Let me start with one. He's in Spain. This is Spanish railway infrastructure manager, one of the largest in Europe. They started working with virtual reality a couple of years ago, taking training to another dimensions. And this year, they're going to make a huge bet for them. I think a huge bet for the industry. They're going to invest 1 million euros, 1.2, 1.3 million US dollars this year to create and to build the next generation of virtual reality simulation. So they think that virtual reality is going to be in the day-to-day basis for, train their workforce. Another one is GE Hitachi Nuclear Energy. We have Christopher Roche speaking today. They did the first post on LinkedIn last week as a company, just saying that stay tuned if you would like to know how we are becoming a leader in applying virtual reality in the nuclear industry. Today, Christopher Roche is going to share with us what they are doing in regards of training, applying virtual reality for training, although GE Hitachi Nuclear Energy as a company, and even the big GE, they are applying virtual reality for other purposes than not only training. Then we have the big CAE, Canadian-based company, big, largest company in aviation, defense, and even healthcare. I saw this Monday. They're going to invest 1 million in innovation over the next 5 years. And one of the areas they're going to invest money is going to be to reinforce their leadership in training by creating digital immersive solutions. So I guess virtual reality in training is going to be, again, another bet. And they are seeing the real value will apply in virtual reality and the ROI behind it. And finally, this is the Spanish Ministry of Defense, so the Spanish Military Health School. We started a project with them early this year, well, last year, let's say that. And they needed, a tool or a technology to train their corps in large-scale multi-user environments, and they bet on virtual reality as well. I'm going to get deep through it. This is a good use case. We don't have any data yet, but this is how more or less some of you, if you have already started applying virtual reality in your companies, it's how you have started. First, identifying the challenge for them. They need to improve the capabilities of medical corps to assistance in highly complex environments, multiple people, multiple victims, and highly complex environments. So the plan is like, okay, I start with a demonstrator, technology demonstrators, to see if virtual reality is the engine, and if I can accomplish what I want using creating virtual reality simulators. In this case, for tactical matters, multiple victim incidents, and CBRN environments. For instance, this is one of the pictures of the demonstration that we are creating with them. In large environments, free room solution where they can have, everybody in the same virtual reality space being trained, and even having people remotely just to see what's going on in the virtual reality environment. So the results that they would like to have and they expect is like, better prepared and better trained professional, and increase the patient survival in highly complex environment. That's why, they can't replicate complex environments, and even with multiple people. So they bet on virtual reality again to do this. So all this said, this is a brief introduction so you understand, the basis of this webinar, why we are talking about the use of virtual reality for training. And I will say, Christopher Roche, just step up, please turn on the camera, share your screen. The stage is yours. Thank you for being here as well. Thank you, Christopher.
Hey, thank you very much, David. Let me get my screen up here and share that. I appreciate the introduction, and I appreciate everyone's time today. My name is Christopher Roche. I've been working in nuclear for a lot longer than I'd like to admit right now. The picture of me in the presentation is kind of an old one, but what we do, I want to talk a little bit about what we do as a company, how we're using VR, why it's really changing what we're doing, and how it's really improving and is going to improve, our production in the future and our performance as well. Not just do things faster, but do things better. So a little bit about what we do. We provide a wide range of services for nuclear power plants worldwide. I've worked in the United States, I've worked in Mexico, I've worked in Japan, I've worked in Taiwan. I've been to Europe, but I really haven't done a lot of nuclear power plant work there. So we'll do everything from disassemble a nuclear power plant after they shut it down. We'll fix it, we'll inspect it, we'll refuel it. And one of the things we want to talk about now is refueling. So when you shut down a nuclear power plant, if you think about it, it's not like the gas tank in a vehicle. You don't just fill it up and when it's empty, you're done. You have to shut it down. The fuel lasts for about 3 cycles. So if you think about it, we replace about a third of it, and then the other third we shuffle. And the newer fuel, and for lack of a better term, is a little bit hotter than the older fuel because the older fuel is partially burned up. So we do a shuffle, but we're moving around these fuel bundles to make sure we have nice, even power across the core. It's a little bit difficult. They're deadly radioactive. They do glow. That pretty blue glow you see down there is actually mostly lights. But when you do pull the fuel bundles out, there is a cobalt blue glow that's pretty impressive. But if you look at it, I don't know if you can see my cursor here, but there's a mast, and you have a person at the top of the mast. And what that's doing is it's reaching down about 80 feet into the water, and you're gripping one fuel bundle by the bail handle, lifting it up and moving it to where you need to move it to. There are 3 people involved in this process. There's the driver, which is the person here that you can see on the upper picture that's actually handling the mast. You have a spotter who is coordinating the efforts and telling the driver where to maneuver the bridge that he's operating and what to do with the fuel bundle. And then you've got a senior reactor operator. And that senior reactor operator isn't one of our team. That's actually one of our customers who is a licensed, so basically they're government certified to be able to operate this reactor. They're there because if we put a fuel bundle in the wrong location or we have an issue with the fuel bundle, we're dealing with reactivity here and we don't want to make mistakes. So it's very, very critical. And to have these three people communicating efficiently, coordinating their efforts efficiently is very, very important. And a lot of times when we start out an outage, there will be over 500 individual fuel moves in each outage, sometimes many, many more. But when they start out, they're still kind of forming themselves as a team and not really, they're not firing on all cylinders, as we say. So this is kind of what we're talking about as a company. When we do training, what we've done in the past is we build physical mock-ups and we train our people on those physical mock-ups. So it's hands-on. So in San Jose, California, we have a full-size boiling water reactor mock-up, and we can take students out there and we can train them to move fuel. We can put them on a mast and they can move their dummy bundles, but they're still fuel bundles, and we can go do that. The problem with that is we have to fly everybody out there. We have one mock-up, and sometimes it's not used for moving fuel. Sometimes it's used for moving something else. So it's got limited availability. And you also have a limited, once again, I talked about we had customer people there. To get everybody together to coordinate that is very, very difficult. Those senior reactor operators are in high demand, and the sites do not like to let them go. And they don't like, especially for a week or something like that. They're very, very skilled, very skilled people. So we were looking at, hey, how can we improve our fuel moving capability, our fuel moving coordination? And this is for not just training new people, but also making sure that our experienced people are maintaining their proficiency. And we started looking at what kind of simulators can we build, what kind of simulators can we put together. And we were coming back with a lot of, that's really not going to work for us. We weren't getting any good solutions. We weren't getting anything that was going to work. We got introduced to Virtualware, and one of our executives in Europe, found the company and was impressed and said, "Hey, look, let's give them a try." So we signed a contract to do a proof of concept with them to make a virtual reality fuel moving simulator, and that's what we're going to talk about today. So if you look at what we were able to do is actually incorporate physical controls that replicate what people do in the field. So this is an actual mast at a nuclear power plant, and this is the driver here, and this is our virtual mast that we have that replicates that. So it's the same kind of grid around there. So the person's going to see that, they're going to feel that. It's going to feel the same way. It's got haptic feedback. This is a telescoping mast, and it's a long telescoping mast. And when those sections hit each other, it rattles everything. This thing is great. I mean, it rattles things just like it does in the field. So it's very realistic in the way that goes. We have a permanent virtual reality room installed in Wilmington, North Carolina. That's our headquarters. We also have a mobile room that's designed to be sent somewhere, set up, and we can put it almost anywhere that we can get power to it and everything else. And what's nice is we can set that up at a customer location. The SRO can go into that room. We can have people in Wilmington, North Carolina, and we can network these two rooms and have two groups that are in different physical locations working together, communicating and operating in the same virtual environment. So we don't have to travel SROs. We don't have to travel our fuel moving team, to the site. We eliminate a lot of that cost, but we still have something that's very realistic, that's very immersive, and that really is focused on that communication, on the coordination, and reinforcing the process that we're trying to train. So this video I'm going to show was taken, and this doesn't look like what I showed you last time. This is one of the prototypes, but it gives you an idea of the user number 1 is the spotter, the user number 2 is the person on the controls there, and it gives you an idea of what they're doing in reality in the room, and then what they're seeing. And it starts off, and I'm just going to play this and kind of talk through it and give you an idea of how we do this. So basically, this is setting up. Everyone's getting in place. They're getting ready to go into the simulation. You see the person holding their hand up. Basically, that's the field movement form. That's the form that they use to say, hey, we're going to move this bundle to this location. Now they're in the simulation. So now if you see them when they look around, it looks like a nuclear power plant. It looks like an actual bridge. There's water. You can see ripples on the water. All of the indications that you'd have are present there. Camera views are present. What user 1's doing right now is we call that circle slash. That's placekeeping. He's testing that. We have an IR sensor on the front of the goggles. So when they're looking at a core map, or when they're pointing at something, they can maintain focus like they would in real life, and they can count over spaces and do things like that. So we're kind of jumping around a little bit, but they're actually lowering the fuel bundle now onto the grapple. And you can see this is a much more rudimentary mast setup, but it was very useful in proving the concept and developing the final one. So you see in virtual reality, all the lights come on just like they would on the bridge. All of our interlocks are programmed into the logic. There's a lot of things we can do here. But I mean, when you look at the environment, it looks just like what we work in. Maybe a little bit cleaner. So they've got a bundle on the grapple now. They're moving it to the next location. So you see, I mean, we marks on the floor showing them where they are on the position, in the core. Looking down, so he's counting over. Hey, here, making sure they are where they say they are. Doing that verification. Then he's looking at the camera as well. And now they're inserting the bundle into the core. So this whole process, and what you can't hear now is their communication, but we've got a very, very formal process for doing this. We've got, it's a very large procedure. It's very scripted. The communications are very prescriptive. It's kind of, think of like an aircraft checklist. When you're doing that, these are the things we have to do every time. Here are the concurrent and the independent verifications that we perform, so we don't put something in the wrong orientation. We don't put something in the wrong position, and we don't have any of these errors that are going to, make our customers have to report to a regulator or something else. So when we were looking at this, what are the real benefits of training in virtual reality? Well, one, we can train in a realistic environment. Sights, sounds, and feels of the power plant are well modeled and they're immersive. It's amazing watching people when they go into the virtual environment, because in the virtual environment, if you're on this bridge, you can walk through the guardrail and you can walk into the water, but it's amazing people won't do it because it's that realistic, it's that it's that impression. It gives you that impression. No, I don't want to do it. And they have to make a physical effort to actually go do that, and it's kind of neat when you do. But when you think about it, sight, sounds, and feel are the critical things here. Smell and taste, we're not that worried about in a nuclear power plant. But coordination and communications are just as they would be in the field. It's the same communications, it's the same indications, they're getting the same verifications. And this is really the critical aspect of the training we're doing. It's not so much the exact feel of landing on a fuel bundle and what it feels like to do this. That's pretty straightforward. That's not what we have to do. Where we make mistakes, and that's really the key thing here, is we looked at where we made mistakes and where we had issues, is coordination, communication, and following the process and doing those verifications. So this is an outstanding tool for that, and it works very, very well. We have lower cost and a higher availability. To train people out in San Jose, first I've got to buy them plane tickets, put them in hotels, get them rental cars, feed them, and all those kinds of things. In Wilmington, I can have this up and running in just a few minutes, and we can be training from turning on all the computers and getting everything set up to actually having people move fuel is probably about a half an hour. And we've got a lot more access to it. We can do a lot more training. We can, really work with a lot more students and teams in this environment than we can in San Jose. Just because San Jose, if we're using the mock-up to do some engineering work or something like that, it's not available for our use. I think the biggest thing we can do in VR that we can't do on a physical mock-up is train for abnormal situations. There are things that come up during field moves. We call them leaners. Let's say you set it and it hits something, and instead of going down in the slot where it's supposed to, it catches on something. Well, that fuel bundle is going to lean. We have to be able to catch that, stop what we're doing, and take the corrective actions immediately so that we don't cause something bad to happen. That's not something we can or are willing to train with on the physical mock-ups, because we can actually damage the mock-up. However, in virtual reality, we can insert problems. We can make something happen. We can change a serial number on a bundle to see if, hey, are you doing your verifications accurately? Are you picking up the right bundle? Part of that is verifying that serial number. We can create those kind of anomalies in the simulation to let the people catch what's going on. In the built-in analytics, so if we put a team in there and we run them through a thing, and let's say they do 10 fuel moves, once we close that session, it gives you all the analytics on what happened. Hey, when did they not follow the process? Because it tracks everything that we do automatically. What was your fuel move rate? Where did you have issues? What was going on, and that helps the instructor communicate with the students and give that feedback that's critical to making sure that we're having effective training, as well as going back and actually reviewing what the students and what the teams did. So what's next? For us, our fuel movement simulator was kind of our killer app. That was what got us into virtual reality. We saw the value immediately, and we started developing this. And I'll tell you, we actually got the final mast in late last week into Wilmington. The final mast design. The team put it together in the room. Within an hour, we had it up, we had it running, and we were moving fuel on it. And it was absolutely impressive. Yesterday morning, we did our first customer demonstration with the fuel moving mast, and they were blown up with the simulation. And we had people in there. We had seasoned fuel movers communicating, coordinating. We had what was going on up on the screen, and we had a whole panel of customers, and they were just blown away by how well it worked, how immersive it was, and how it focused on exactly where we've had issues. And they can see the value there. So the other thing they're looking for is fuel move rates. When we shut down a nuclear power plant, it costs a lot of money. When these teams start off, they typically aren't as efficient and fast as they are toward the end. So once again, another benefit of this is if we work with the teams and get them proficient, working together smoothly, coordinated, and then put them in there, we may be able to cut down some of the time for this refueling outage as well, while maintaining quality and actually improving quality, because a lot of the fuel movement errors we have are at the beginning when the teams are getting used to working with each other. So some things that we're working on in the future: dynamic supervisor training. Supervisor training is one of those things that's very, very difficult to do. You can talk about it, you can set up static environments to go look at, but you really can't put someone in a dynamic environment and have consequences if they don't take the right actions. And this is an environment where you can, and those consequences can be very, very impactful. If you're watching a team that's doing a rigging evolution, for instance, and they do something wrong and the supervisor doesn't catch it, you can have something fall, you can have a load drop or something like that. In virtual reality, we can model that, make that happen. In real life, we don't do that. And believe me, it's impactful in virtual reality, and it's going to have a lot more. You're going to have a lot better retention, and you're going to have a lot better internalization with someone when they do that. Familiarization training. One of the things we do at our mock-up in San Jose is we can actually drain that down, and we put people in a man basket and drop them down into the vessel and look at the components that are down there so they can see, hey, this is what it looks like in real life. And what people usually do is they remember the man basket ride because they either loved it and they thought it was fun, or they were scared to death and they didn't want to do it. But all the rest of it, they never talk about. What we can do with virtual reality is we can take our inventor models, we can take all of our reactor models, put them in virtual reality and put someone virtually in there. They're looking at the same type of thing, except we can show them a much broader range of components. We can show a much broader range of areas, and we can, facilitate that familiarization training more completely and less expensively. And the other thing that we're really focused on right now is supporting new designs. We want to let design engineers see what they're developing almost in real life, in real size as they're doing it. We also want the people who are experts in servicing to be able to go in with the design engineers and say, hey, look, you put this here. When we do this, we've got to bring things in this way. It's not going to work. Here's how we're going to have to organize the refuel floor. Here's how we're going to have to do this. And we're going to see, wonderful benefits in our design for maintenance. And that's something that we've always kind of had to overcome, building physical models and doing things like that. I think we'll really be able to get in there, drive the proper dialogue between the people that design and the people who service. And really that initial design is going to be much, much better than it was. And it also gives people an opportunity to see what they're working on. That's basically what I have, David. Are there any questions that have come up, or would you like to wait until we switch off?
Well, I guess we have many questions, and as we have time, I will drop you at least 3 in 1 question. Okay, and maybe you need a panel, then we have more time. If not, I will send it to you, and maybe we can answer them, and give them to the audience, next week, maybe with the recording. So 1 in 3 is, this setup is a single installation on one side. What's the process for installing the VR simulator? Do you have to train the tech to set up, or this has not been moved to a production level? It's still maybe in pilot. Thank you, Mike, for this question. So, Christopher?
No, actually, it's a great question. So we have one installation right now that's set up, but we also have all the equipment for the mobile room. So basically what we'll do is we'll move the mobile room and all this equipment to the installation. It takes about 12 hours, 12 hours for about 3 people to set up the room, set everything up, and then they're ready to go. A lot of our power plants are centrally located. in Illinois, for example, we've got 3 power plants that are very, very close. If we set it up in a central location, we could have people from all those 3 power plants come in and train at once. So we have, so yeah, it's a great question. Right now we have one simulator set up. We've got another mobile simulator that's able to be installed remotely, and we're working on ordering a 3rd.
So right now,
does that answer the question?
Yeah, I guess so. One of the questions is, okay, are you still in pilot, moving to the production line? And what you're doing now, it's like moving to the production line. I mean, you are, starting with this, you have that fueling simulator, you start to, bring VRAI training at scale. And this is, as you mentioned before, this was the killer app to do so.
Right, and like I said, so this was what got us into it. So now we're bringing virtual reality into, and we're exploring every other place we can use it. There are some things like say a hands-on like torque training, where we're training people to torque a flange and using torque wrenches, where virtual reality is not the best method. However, we're looking at augmented reality to do some of that work, and we're looking at augmented reality to do some refurbishment work where we can minimize the potential for mistakes by superimposing procedures or part diagrams or something like that while the people are doing the work and doing that. So yeah, like I said, that's part of this what's next slide, is dynamic supervisor training, and we're developing content as we go. Like I said, we just got the field movement simulator done, and unfortunately, we've actually driven quite a bit of investment with our company based on this field movement simulator. And now that we have it, and we can show our leaders and everything else just the value of it, we're going to drive even more investment. And I see us spending a lot of time. I see us gaining a lot of advantage, and getting a lot better because of this.
And it's amazing. You are joining for sure. This VR is now movement. The last question regarding of sickness, and how long does a trainee be in the MERS environment? Because here maybe in the past there were like issues when you spend a long time in immersive environment. But I know, as we were part of that test that we've seen in the video, the field service team spent great amount of time without any kind of sickness, being trained.
I tell you what, it's a great question in the environment that we have, because it tracks where you are. What we found is that very, very few people are sensitive to it, because when you move in real space, you move in virtual space the same way, so you don't get that disorientation between your inner ear and what you're seeing, which causes that motion sickness. We've had a couple people who are sensitive, and that's something we have to work with. But most people can be in the environment for well over an hour and not suffer any ill effects. They can pop in and out, and it's been very, very stable as far as that goes. One of the things that we do have is we have people in there acting as spotters, so no one runs into a wall, because virtual space is a lot bigger than actual space. So there are safety things that you have to go through. There are some things that you have to manage. And people get so immersed in it that they'll walk right into a wall because they don't see that wall in virtual reality. So, but yeah, really, as far as people being comfortable in there, it's actually very, very comfortable. I've been in simulations where games and things like that, where it really upset my equilibrium. This doesn't bother me at all. And it's amazing how much this technology has gone from a technological, interesting thing to actually a tool that we're using and we're gaining advantage as well as improvements from. So.
Well, thank you, Christopher. And actually, that gives me the opportunity to answer one of the test questions about these Unity-based applications, a Unity-based solution. Okay, that's simulator. And another thing, as you mentioned, right now, it's about why you haven't used, let's say, Quest or Quest 2, and it's because that tracking part, because you need an absolute tracking so you can reduce even this kind of sickness that you can get, with, that disorientation, mainly with the tracking system. So thank you, Christopher. Thanks for your time. This is amazing. We have more questions. Let's see if we have time in the live Q&A panel, but at least we have time to answer some of them. So thank you, Christopher. Thanks for your time. Niall, you go next. From fighter pilot to the factory floor, virtual reality and the potential to democratize simulation training. Step up, share your screen, turn your camera on. It's your turn. Thank you.
Is my camera on? Can you see me? Can you hear me before I start?
Not yet, at least me. I can see your screen, but I cannot see your camera.
Can't see me. Interesting.
No worries at all. I mean, Niall, you're going to start. Okay, if it's not properly working right now, no worries.
I sound better than I look at the moment anyway, in terms of it is very hot here in Dublin. I might actually just even turn off that camera if you're still getting just the grey screen. So I think someone earlier was talking about painting out their sweat beads from the recording.
Up to you,
Niall. Similar situation here. You can hear me okay, can you?
Yes, perfectly.
Great, cool. So yeah, I guess I'll start by just thanking ETSA for having us present here. It's obviously great to be involved in an organization as prestigious as the European Training and Simulation Association. And hopefully this will be a reasonably entertaining maybe or relevant presentation to the attendees. It was also great to see Christopher there, and I think he's maybe set up a lot of the stuff I'm going to talk about. I'm going to take maybe a slightly different approach to what I'm going to talk about, and maybe not talk so much about specific projects, maybe talk more generally about VR, and then maybe use a couple of projects we've worked on to reference that. I'm conscious I'm trying to be sort of relevant to the audience rather than turn this into maybe a salesy type presentation from my perspective. So I guess that's kind of the general context of the maybe slightly lofty title of Fighter Pilot to the Factory Floor. And how virtual reality has the potential to democratize simulation training in general. So I guess I'll start maybe with a brief introduction to the company and to myself. So my name is Niall. I'm the Managing Director of Product and Customers at VRAI. And as a company, I guess we specialize in data-driven virtual reality simulation training. So that's all we do really is VR training merged with data. And we've been doing it for probably 5 years now as a company. We were established in 2017. And we have offices in both Dublin, where I'm based at the moment, and in Newcastle in the UK. We've worked across industries really, but like we sort of focus our attention on what we define as high hazard industries. So that'll be defense, security, aviation, energy generation. So it's really interesting. There's the nuclear stuff there, and also manufacturing. And in terms of customers we've worked with, over the years, we've worked with the United Nations in Somalia. We've done projects with Samsung, with Pfizer, pharmaceuticals, and we're currently working with the RAF around codifying something called airmanship, and that's a project I'm going to touch on a little bit later. We're also working a bit in the offshore wind industry in terms of energy generation at the moment. We've also actually just started a project with the Irish Defence Forces, a reasonably big simulation project. In terms of like our insight as a company, really, and I'm going to again touch on this later, is that VR is a great way of presenting data to people. And I'm conscious that the sort of overall theme today is about VR and how it can influence or benefit simulation. So I'm going to maybe talk a little bit about simulation in general and sort of a little bit of the history of simulation, and then maybe try and bring that back to VR, again, to maybe keep this maybe slightly different to some of the other presentations today. So I guess maybe without further ado, I'll get going. My general hypothesis here is that that simulation training is something that's been sort of the sole preserve of maybe high value jobs or like high risk jobs, stuff like fighter pilots or surgeons or those kind of jobs. But what we're increasingly seeing VR is enabling is projects like the one we've just heard about, that it's about taking this technology and allowing it to be applied to other industries. I'll say maybe one more thing about the company before I move on, and it's kind of an important thing for me personally. We've adopted something called the triple bottom line as the way we measure our success as a business. So we don't just talk about our profit and how much money we're making. Really, we're set up to measure our effect on both people, planet, and profit. So that's how we measure our success, and we're currently in the process of getting B Corp certification. That's kind of a passion of mine, and I'm happy to talk about that maybe separately to sort of a VR discussion. It's kind of more of a business innovation or whatever, rather than VR related. So as a company, we talk about this idea of codifying wisdom. And so for us, this is what simulation is about. It's about codifying wisdom gained by experience and passing it on to the next generation. And about doing that in sort of an efficient or effective and efficient, mostly cost efficient way. And so I guess the challenge always is like, how do we do that? And I guess, how do we use technology to do that? And then to go even sort of further removed, it's how do we use VR to do that? But really the way we think about VR is like, it's at a basic level for me, a VR headset is just a fancy monitor. And so like, sometimes we can tend to overplay like the revolutionary impact VR has had in simulation. And I feel like that is definitely a part of it, but there are also other technologies converging to bring together this idea of codifying wisdom using technology. And again, I'm going to maybe talk about that as I get through the presentation. But for me in general, like thinking about simulation training, flight training in general is a great example of how different technologies have come together over the years in order to get this idea of codifying wisdom. And so what I'm going to do now maybe is go away from VR for a little while and talk a little bit about the history of simulation training in flight, in aviation in general. So the reason this is interesting to me, like I have a sort of general interest in aviation anyway, and we work with sort of aviation customers, but I think it's really relevant when we're talking about simulation, because really the history of simulation training in the aviation industry is nearly as old as the history of powered flight. So what I have up on the screen here is something called the Antoinette barrel, and that dates to 1910. So think about like the first Wright brothers powered flight was in 1903. And so very shortly after that, aviation was already thinking about how do we simulate the experience of being in the air in order to make the actual process of flying a plane easier or more intuitive and safer ultimately. One of the interesting features about this barrel, if you look at the picture carefully, you can see that the pilot, it's different to modern flight systems. He's using two wheels to steer the aircraft. I know Bob is going to talk about UI and XR in the next talk, so I maybe won't steal too much of his thunder, but like what's interesting here is like, I would argue that maybe it's bad UI is the reason this simulator had to be made, because the UI of the aircraft maybe wasn't that intuitive to pilots. But ultimately the idea here is that the pilot is allowed to experience what it's like to fly the aircraft before he actually has to go and do it for real. It's worth pointing out that actually Antoinette were aircraft manufacturers, so they made both the aircraft and the simulator, and because of the way they designed the UI in the aircraft, they had to have a simulator to show people how it worked. Maybe jumping forward a few years, I guess, from then, maybe a decade or so. Again, anyone sort of broadly familiar with simulation history probably recognizes this Link blue box, which, you know, Ed Link sort of being considered the sort of the founder of simulation training as we know it today. And so this dates back to 1927. So again, without getting into too much detail, because I'm sure a lot of people know this story already, but he had a boyhood fascination for flying, but broadly he couldn't afford it. So his father was a piano manufacturer, and he basically found a load of bits of piano organ and bellows and built his own flight simulator to reproduce the experience of flying an aircraft, because he couldn't afford to experience it himself for real, because it was quite an expensive thing to do, and obviously still is. So he started manufacturing these simulators, and they were seen as a novelty first. So they were sold to fairgrounds and as amusement rides. But it was really only around the 30s when the US Army started taking over the Postal Service in the US, which is an interesting story in itself that I won't get into today. But they had 12 fatalities over 78 days. And so at that point, they realized actually, you know, aviation, particularly flying with instruments, is something they weren't able to train people for in a real aircraft. Training people how to perform instrument landings on overcast days was something they couldn't prepare for, and people were dying as a result of that. So they started looking for solutions, and long story short, they came to Ed Link with a view to procuring some of these blue boxes. One of my favorite stories around how it was ultimately sold to the US Army was they arranged to have a meeting at one of the airfields in the US, and basically Ed was supposed to fly in himself. And basically the generals all decided actually this isn't going to happen. There's no way he's going to be landing in these conditions. It was overcast and foggy on the airfield. And then sure enough, they heard the sound of his aircraft coming in, and he performed a perfect instrument landing on the runway. And so that proof of the pudding was that he was able to do that. And that's how he sold his first of these simulators to the US Army in 1934. Moving that forward maybe another 10 years to the Second World War, the RAF, who again we're doing a bit of work at the moment, so I'm interested in this part of the story. But the RAF in the Second World War bought 10,000 of these simulators, or sorry, that's not true. There were 10,000 built over the course of the Second World War, and it said that at one point there was one simulator being built every 45 minutes. So again, like I found this fascinating when I started reading about it, that 80 years ago this industry existed, and there were 10,000 of these simulators built during the Second World War. And what I also find really fascinating about this image, which is, like I said, it's from the RAF during the Second World War, is that it actually contains a lot of the components that we recognize from modern flight simulators. So it's got the proscenium. Now, obviously, the clouds aren't moving as we look at the background here. It's got the pilot sitting in his aircraft, performing his instrument with accurate instruments. It's on a motion platform, so he can move around. And then we've got an instructor speaking to him over comms. Again, it was interesting to hear Christopher talking about the multi-user experience in VR. And like again, for simulation, that's something that's been around for 80 years. And then it's kind of maybe harder to see is on the table beside him here, there's a map. And on this map, it's plotting the course that the pilot has flown. So it's this idea of an after-action review and capturing data from the simulator that can then be used to discuss the pilot's performance afterwards. And so again, that's something that we as a company feel like is one of the real benefits of VR, and it's something I'm going to talk about a little bit later in the presentation. Ultimately, there was 500,000 pilots trained from every allied country on EdLink simulators during the war, which is a staggering number really when you think about it, which leads to the quote here from the Chief of Staff of the RAF during the Second World War. And he says that the Luftwaffe met its Waterloo on the training fields of the free world, where there was a battery of link trainers. So I guess overall the point I'm trying to make here is, like, in aviation training, there is a legacy of simulation and simulation at scale. And for me, that's what start to bring it back to VR. VR allows us to do. Again, jumping forward a few years, like when computer graphics start to improve, that desktop simulators start to become a thing that people can do, training in computers. And Microsoft built their first flight simulator in 1979, really to show off the graphical capabilities of Windows PCs, but rapidly became a way that amateur pilots could start to practice their skills without having to go to more expensive simulators. So we see this idea of, again, as technology evolves, the cost of doing simulation training also reduces in parallel. And so for a couple $100, anyone can set up their own simulator at home. Again, jumping forward to maybe the modern day, and I'm sure some people recognize this as the F-35 simulator. And I'm sure as well that there's a general awareness that for the F-35, it's one of the first fighters that has no two-seat variant. So the first time any pilot flies the aircraft, they're flying it solo. Also, as part of the F-35 training program, 45 to 55% of the training takes place in the full motion simulator. This is obviously quite an expensive piece of equipment, this F-35 full motion simulator, but compared to the cost of the aircraft and the cost of training the pilot, which is about $10 million, it is affordable. And to bring it right up to date and start bringing VR into it, I was really excited to see this project between Vario and VRM being announced recently, that it's the first EASA certified VR simulation trainer. And so for me, that's again, taking this story maybe to the modern day and bringing it back to VR, that now there is flight simulation training certified in VR headsets, which is, for me, like that's the ultimate aim of any simulator, is that it can provide certified training. It's all well and good to do proof of concepts, but until it's actually proven to show that the job can be done for real in the simulator, really they will stay as proof of concepts. So that's kind of my sort of brief overview of aviation history, and I'm hoping now to try and bring that to something more contemporary and start talking about VR, and so what it brings to the sort of simulation party, and how it can evolve the legacy of what we've just talked about. So for us as a company, we talk about this idea of risky, remote, or rare environments. And again, I think the nuclear example from the last presentation really highlights that. It's this idea of situations that are difficult to get to for real, it's difficult to reproduce for real, or they're rare, or they're risky to perform in the real world. And this is where VR and simulation in general really adds value. And so for me, thinking about that further, that virtual reality also allows us to democratize this idea of these simulators. So something like the F-35 simulator, or even going back, like they're quite expensive pieces of technology. Like thinking about even a full motion flight simulator at the moment, like a sort of, I use the term loosely, but a basic one where you're sitting in a dome with maybe 5 or 6 projectors each projector costing $25, maybe $30,000. The cost of the bulb being a couple of $1,000s to replace the bulb that lasts maybe 400 hours. Like, again, to go back to my first point around, like, is a VR headset just a fancy monitor? Well, like, if it's a fancy monitor, it's like the VRAI headset in the previous example, that's a €6,000 headset replacing maybe 100 or 200,000 euro worth of projection equipment. So again, the idea here is that, like, it's taking something that's expensive and making it more affordable. But again, like, when I talk about, like, from the fighter pilot to the factory floor, where we see it going is actually beyond that. So it's taking something that was the preserve of these high value jobs and allowing it to be used in other enterprises. So in 2018, we did a project in Somalia with the United Nations Mine Action Service. I'm going to go a little bit of a tangent around affordability, but try and bring it back again in the end. So, and this was kind of the way, I guess, early VR projects went, is like, it's kind of standalone, single use. And what this project was commissioned to do was to show how difficult it is to identify IEDs in Somalia. So we filmed on a road in Somalia. We built a VR experience around it, combining the video footage and interactive elements in order to make an experience that someone could put on a headset, drive down a road and identify IEDs. As part of the experience, there was an after-action review. And in that after-action review, you were told, you drove down this road for 5 minutes, you identified one real IED, but there were actually 4 IEDs in the scene. And of those 3 that you missed, you actually looked directly at 2 of them, but you didn't identify that they were there. And so for us, that was a really interesting insight around sort of the other power that virtual reality offers over maybe more traditional simulators or even real training, is that it's this idea of being able to sort of identify what people are doing as they're going through their training experiences, with sort of eye tracking and gaze tracking being a really sort of tangible benefit of that. So instead of just being able to, say that, yes, it's hard to spot IEDs, or in the real world that you're putting down IEDs and the student is told to spot them, and that in the virtual world, we can say, well, you actually looked at the real one. We can tell you that for sure. And in an after-action review, we can show that you've looked at it. So this idea of virtual reality being a great way of presenting data to people, but also a great way of capturing data from them. And so it's kind of in that context that we've built a product that we're calling Heat, which is basically an underlying data capture framework for virtual reality. And I'm going to use that maybe to take it back to aviation and talk about a project we're currently doing with the RAF. And so what we're trying to do with the RAF is codify something called airmanship. And so airmanship is the non-technical skills required to operate an aircraft safely from planning to debrief, which I guess for anyone not familiar with aviation, if you think about like driving your car, technical skills would be making sure you're in the right gear, making sure you're holding the steering wheel correctly and that you're turning it to go around corners. Non-technical skills are things like checking your mirrors, being aware of your road position, being aware of other traffic, making sure you don't crash into things, navigating from your office to your home, or navigating from point A to point B. So it's kind of the non-technical skills required to operate the aircraft. And currently it's quite a subjective measure. So it's ultimately an instructor sitting beside the student or sitting behind the student in an aircraft, taking notes on what they do. I think I mentioned to some people at the start of the call, like I was in with the RF actually yesterday, and we were talking about, how eye tracking is adding benefit. And like they were talking about, a 2-seat variant of an aircraft where the instructor is sitting behind the student, and the student knows what the instructor is looking for. They're looking for them to be looking around, but actually because they're kind of, they're new and they're not certain about taking their eyes off the instruments, they keep their eyes pointing forward, but they just move their head around. So if the instructor sees the head movement and that's achieving what they think they want them to do, but actually they're keeping their eyes firmly locked forward. So they're actually not performing what they've been trained in, and the instructors have no way of measuring that. So this idea of being able to capture data using the VR headset as they go through the simulator is really adding value. At the start of the project, we did sort of a survey. So any sort of project that we start doing, we talk to as many end users as we can before we really start building anything. And for me, this was one of the really interesting points that came up from those interviews that we did. So this guy is an instructor in the RAF. He's very experienced. I think he has 25 years of experience in the RAF. And so what he said was, instructors sometimes find it hard to quantify what's causing student behavior. They can see the effect, for example, the aircraft speed dropping, but it's hard to assess if a student is aware of what's causing the problem. So have the students checked their instruments for altitude, and has the instructor actually seen what the student was concentrating on when the error was made? So again, to think back to that example of like the student is looking straight ahead out the window, keeping their eye on the runway or wherever they're trying to get to, but actually their instrument is telling them that their speed is dropping, so they need to increase throttle. The instructor has no way of currently seeing that they've looked at the speed before they increase the throttle. Cause and effect need to be correlated, and instructors don't always get it right. Being able to quantify the actions they take in order to assess and correct the problem would be a benefit in an after-action review. So like thinking about an after-action review as well, like in a subjective world, the instructor says, this is what you did, and the student goes, he's got it wrong, that's not what I did. Like I feel like I did this other action and I did it correctly. But again, the data doesn't lie. So by being able to show the student, well, you know, so for this project, we're measuring data every 33 milliseconds. And so here's what you did at the point that we're talking about. And here's the inputs that you gave the aircraft. Here's what you were looking at. And here's the action that you took. And so that's really adding value to the pilot training process. So this was the objective of the project, was to integrate HEAT, which is our data capture pipeline, with an existing flight simulation software in order to quantify airmanship in the ORF pilots. So again, like thinking about VRAR and building simulated environments, increasingly like where we see it going is, it is this idea of convergence of technologies. So on this project, actually, we didn't make any VRAR at all. We built on top of or beneath an existing flight simulator. And so what we do is take the data that that simulator is already generating, combine that with the data we can get from the VR headset, and then start to, well, I guess store it first and then start to identify patterns in the data that would indicate good or poor airmanship performance. Again, probably similar to what Christopher was talking about with the after-action reviews that they do in that nuclear experience. I'm going to skip over this because, again, I'm conscious that we're running short on time, and I just want to get to the end of the presentation. So to take these concepts and apply them then to the factory floor, as you know, we've just talked about the fighter pilots and the high end, or the sort of technologically advanced stuff that VR could do. To bring that back to the factory floor, we did a project with IAG Cargo, so also in the aviation industry, and where we've found that these technologies initially were getting uptake was industries who had, I guess, a legacy of simulation training. So IAG, obviously British, or the parent group of British Airways, they were familiar with simulation training from training their pilots. But what they thought they could do is use VR to train people who work in the warehouse. So again, without getting into the detail of how air freight works, IAG have a huge warehouse, 6 stories high, the side of the runway in Heathrow Airport in London, for processing their air freight. And so what the challenge they have, though, is because it's an airside operation, it's quite hard to access for new recruits. So they only really ever see the whole operation on their first day for like a 2-hour walking tour. And so then they're put in their own area and they don't really have an understanding of how the whole operation works. This is problematic for a whole host of reasons, but primarily because they don't understand what their other colleagues are doing. They have trouble delivering what they need to their colleagues in a way they need it. So we made this experience in Heathrow. This is kind of the view out the window from Ascentus, so you can see how close it is to the side of the runway. And so you're looking out at the main runway at Heathrow Airport there. And so the idea was basically to enhance this idea of understanding of warehouse operations, and to do it using simulation technology. So how do we reproduce the idea of the warehouse virtually? And we did it a few different ways, like we did 360 video, we did fully immersive VR, and combine them all into sort of a blended learning experience. And so the outcome of it was this, that since working with us to create the virtual tour of Ascentus, 94% of users said they'd learned something new compared to the physical tour, which is interesting. So they'd actually learned something new even over the physical tour of the building. And their understanding of the operations had increased from an average of 5 out of 10 to 8 out of 10. So again, it's a clear KPI, clear improvement in performance. Moreover, they've managed to reduce the timings from 90 minutes to 15 minutes. And so this was kind of an unexpected benefit, which I guess we should have anticipated. But what was a 90-minute tour became a 15-minute tour. It meant it was repeatable and you didn't need someone to walk you around. And so it also inspired colleagues to explore how virtual reality could be used in other parts of the business. But I guess like the reason I include maybe both these projects is that idea of like VR is really adding benefit to industries that have a legacy of simulation training, but really where the democratization of it is coming from is where it spilled over into industries that maybe couldn't afford to do simulation training before because the barrier to entry of the hardware was too high. Maybe skip over the next one and go back to my first question, which is how do we codify wisdom? And so for me, it's through a combination of technologies. So as I said, like we're a data-driven VR company, but we combine a bunch of different technologies in order to make simulators that improve learning outcomes. So like I would sort of suggest anyone who's looking at VR as a technology also consider these other adjacent technologies. So cloud-based user profiles or onboarding. So, and this is an important point that I'm sure Bob is going to talk about, like this idea that everyone's experience of VR isn't the same. So in order to train people effectively in a simulator, you have to make sure that understanding how the simulator works isn't a barrier to learning. Make these bespoke virtual learning environments. We include dynamic data capture to monitor performance. We're also adding biometric sensors to what we do to add another level of data to understand the person's performance in the experience. And then finally, when we have all that data captured, what we do is apply machine learning across it to start to generate insights like what does good airmanship look like. That's basically my presentation, but I'm going to finish maybe with one story to bring it back to democratization of technology. And it's back to EdLink. So Ed completed his first flying lesson, actually interestingly with Charlie Chaplin's brother, in the sort of the early 20s. And he paid $50 US at the time to sit in the back of a two-seater aircraft while the instructor flew him around the sky. And so while he really enjoyed the experience, he actually didn't learn very much about how to fly the aircraft, and kind of realized actually it's quite an elite thing to do. So that's kind of part of his motivation to build his trainer. And like interestingly, when he started then selling a full flight training program using his simulator, he had reduced the cost to $85 to complete basic flying training. And so to take this sort of in a full circle around like what I'm trying to, I guess, get across is simulation technology really democratizes the barrier to entry to industries. So industry like has always been about democratizing this industry. So the simulation industry has been about democratizing training and opening up opportunities to those who don't have the means to do it for themselves. And so for me, virtual reality and the convergence of the other technology we've talked about should continue that legacy. That's kind of what I have. There's my contact details if anyone wants to get in touch afterwards, but I'm looking forward to the Q&A session afterwards.
Thank you, Niall. Thank you for your session and your insight you have shared. I have right on two, I think it's just to summarize. One is that, VR technology is ready. I mean, that's why we are talking today about, we have this VR, it's ready, technology is ready to be part of, any company day-to-day training basis. And the second part is the certification side of this. That you can even, because certification is really, really important, I think for Christopher in the nuclear industry, it's really important, the aviation industry, military industry is very, very important. And now you can even certify anybody that, was in the training process, in that virtual reality simulation, you can be, those people can be certified. That's a huge difference right now in the industry. I have one question for you in regards to the IED VR training in Somalia. James asking if it is already in use, that project have already developed.
Yeah, so that project was 2018 actually, so it's maybe 3 years old, and really it was for us at a company at that point, it was kind of a crossover project insofar as it was kind of part marketing, part training. So really the challenge we were given was the UN had this issue around, like there's two sides of the UN, there's sort of the civilian side and the military side. The civilian side were sort of asking the military side why our convoys keep getting attacked by IEDs. The military side were saying, well, because it's kind of hard to spot IEDs. So that's why they commissioned this experience to sort of show people, to let them drive down one of these roads in a safe way without exposing themselves to the risk, and sort of show them, well, like this is a difficult thing to do. And that's where the after action review part came in. So you can actually definitively with the data say, you looked at that IED, you didn't see it, it's a hard thing to spot. And so it was really effective. There's a video, I think, on our website that sort of shows the couple of days we did over there, putting people through the experience. And like they all come out of it. Like my favorite person who came out of it actually was the camp counselor in Somalia, whose job it was to counsel people when they came back post-traumatic stress. And she had never been outside the camp. And like her comment coming out was, now I understand what my colleagues do. And so for me, that's a really powerful use of VR. It's this idea of spending a day in another man's shoes or walking a mile in another man's shoes to understand how they do their job. That's maybe getting into soft skills training.
Let me tell that we are going to answer all the questions. We try to do that. We send them to our panelists. So now you have more questions that maybe there is just to answer all of them. That link, so they can watch the video about this project as well. We will share with everybody. So now we have to move to Professor Bob Stone. avoiding the risk of technology push, human factor for the effective exploitation of ETSA and defense training. Thanks for joining us, Bob. You have a great experience here in the massive ecosystem. I'm not saying you are old, okay? Jokes apart. No, jokes apart. Thank you for joining us today. I know it's really important. That human factor, I guess, is really important in this, ETSA virtual reality environment. So the stage is yours. Go ahead.
Thank you, David. Thank you, everyone. Welcome to my chat, which is from a seriously hot Cornish caravan in the south coast of England. It's absolutely blisteringly hot here. For those of you who don't know me, my name is Bob Stone. I'm actually emeritus professor at the University of Birmingham. I officially retired about 2 years ago, but I'm now taking on an emeritus professor role with my team, the Human Interface Technologies team, carrying on doing consultancy work, consult with various companies across the UK, in Australia and the US, and 34 years in virtual reality. Yes, I'm old. David is right, I am old and I can't get away from that. But I think that's kind of behind the presentation I'm going to give today, because I want to take you back 27 years, because the lessons learned in 27 years, and David is keen to get lessons learned, really have formed the way in which we approach projects today. And why, as many of you will know, I'm rather skeptical and rather vocal on things like LinkedIn, and I believe for very good reason. So you take us back to 1994, when we had our first major close call. This is a contract we almost lost. We made some fundamental mistakes, particularly in my background in human factors and applied psychology. So we were being funded by the National Health Service in the UK to investigate the use of virtual reality for future training for keyhole surgery, laparoscopic cholecystectomy. And this is the kind of thing that you see for keyhole surgery. Small teams, they're injecting instruments into an inflated body and they're watching what's going on with the camera. And the reason they were interested in virtual reality was because some of the things that Niall's talked on is that they wanted to be able to objectively identify when a surgeon was ready to transfer from open surgery to keyhole surgery. So they wanted to offer a sensible and data recording capability to candy, grapes, and chicken skin. This is basic, intermediate, and advanced course and advanced training. All inside a plastic box with a camera stuck in the side. No idea when the surgeon was competent enough to go and practice on a real human, but that's what they had at the time. So virtual reality, 1994, we said we have got to get these guys some technology. And we came up with this solution. We came up with and remember, this is 1994, deformable tissue on a £250,000 graphic supercomputer, silicon graphics at the time, reality engine. We came up with a glassless auto stereoscopic display, because of course the surgeons wanted stereo. They wanted to be able to see the depth and distance in the bodies that they were interacting with. And we came up with a haptic feedback solution. As you can see here, rather Heath Robinson, but nevertheless, it did actually give a fundamental sense of force and touch. Not that dissimilar, I have to say, from the technologies that we see today. And we were absolutely slated. We almost lost the cost of the contract. The surgeons came in, saw what we'd done, and many of them just walked out, completely walked out. Why have you done this? We can't afford this. If you pull the tissue that far, you're going to kill somebody. So we had to go back into the operating theatre, and I went back in with my human factors hat on. And literally 3 afternoons of observation of these guys on the left here carrying out their work. And what did we find? We actually came up with something that didn't provide these guys with a physiologically or anatomically accurate representation of the human body. We came up with these psychomotor sort of primitives, if you like. What we were trying to do is to train these guys to learn how to use their tools in almost like a teleoperation, remote application, rather than them trying to identify individual pieces of anatomy. Because God help us, we would hope that they would be able to identify the abdominal anatomy by then. The output of this was that the minimally invasive surgical trainer VR, and it was VR because the real-time interaction with computer-generated databases was a real success. We just made it. For 10 years, it was the de facto surgical training solution at the Ethicon training institution in Germany, and it went on to be sold by Mentis of Sweden, for which I never got a penny. But hey, people have been telling me I'll be a millionaire next year since I've been doing virtual reality, and I'm still waiting. But what did we learn? We learned an awful lot. We learned that so-called immersion, which is a term I'm not particularly fond of, using virtual reality headsets is not a prerequisite. That's the same is true today as it is back then. And particularly back then, with the quality of the headsets, there was no way that we could even attempt to display this kind of fine information. And we were recording, of course, we were also, just like Niall was saying, we were recording the movement efficiency, the reaction times, and so on of these guys to give us an objective output. Striving to achieve the greatest possible fidelity or realism is also not a prerequisite for effective training. That is also true today as it was back then. And simply assuming, and this is where we went wrong, and probably one of the reasons I'm quite vocal, was simply assuming interactive technology is bound to work based on what you read in trade magazines, in marketing magazines, and particularly those dreadful marketing reports that we seem to get once every 6 months in this community. It's a surefire recipe for disaster. I mean, the hype is something that this community has had to live with for many, many years indeed. Crucially, and this is a slap on the wrist for me, developing a virtual reality without a sound human-centered design foundation is foolhardy. And we've never done a project since that doesn't have that embedded within it. And equally, not engaging with end users until later in the design cycle is not acceptable. Neither is it acceptable to engage with them only at the beginning. You have to go throughout. What we did find, and one of the things that we've been looking at ever since, is mixed reality. Not mixed reality in terms of Windows mixed reality headsets, because they're VR. Not mixed reality in terms of the HoloLens, which they call that, because that's AR. Mixed reality, where we're using elements of the physical real world to enhance the believability of the virtual elements, we felt then was going to become a major element, an important element of future VR-based training, particularly with things like haptics really not being in existence and still not in existence, to give credible senses of touch to a number of crucial applications, particularly in surgery and in certain aspects of defense as well. So how do we practice what we preach? And this goes back to what Chris was talking about interestingly. Remember, this is back in 1993, 1994, we built a simple cherry picker, very similar to what Chris was talking about, wooden framework. And you can see here the guy is using a cyber glove, he's using a virtual research flight helmet, good old flight helmet. And his task was to use a simple control panel to move this virtual cherry picker close to the area where he wanted to carry out work. Yes, we did look at haptics. Some of you may be aware that I invented the first haptic feedback glove, Teletact, back in 1990. And to be honest, in fact, if you blink, you'll miss the haptic effect on this video. You just the little air bladders are actually inflating there even as I speak. And even today, I'm very skeptical that the haptic systems that are out there, which are incredibly expensive, not too reliable from what I've been told, and certainly unwearable for sustained use. Haptics would never have actually delivered the kind of training that we wanted. So we were stuck with interacting using gloves, but using mixed reality, using hardware elements to make that illusion of carrying out Rolls-Royce jet engine maintenance a lot more credible than had they been using an Xbox controller or something crazy like that. We built on this during 2003, 9 years, 2003, 2012, and I joined university in 2012, and we were lucky enough to be deeply involved with the Human Factors Integration Defence Technology Centre. Sorely missed initiative, one of the best MOD funded initiatives ever, never been matched again, in my opinion. But during that, we were able to take these lessons learned and apply them to a wide range of concept demonstrators, all led by human-centered design procedures. Army ID awareness. Could we put together an Afghan village in less than 7 days with all the cues necessary for patrol to practice looking on a patrol going through an Afghan village? Diver mine location, diver mine type awareness, again with objective data tracking the individual movements of the diver around a series of pre-programmed objects, some false alarms, some actual targets, rules of the road, shipping for the Royal Navy, and so on. It goes on and on. And we were able to then combine these into a series of guidelines. And this document that I prepared back in 2012 is as relevant now as it is back then. Maybe some of the case studies in the back of the document are out of date, that's fair enough. But I think some of the issues that we raised was still very much on our radar today. So just some examples of where we use virtual reality and where we use human factors to hopefully deliver something that was not just a concept demonstrator, but would work in the real world. Tornado avionics trainer, this is for RAF Marham. No headsets were specified simply because of the actual quality of the headsets. They would not be able to resolve the individual replacement unit detail that was necessary. No gloves, they're far too unreliable. No gesture input, I mean, they're far too unreliable today as well. But interacting with a complete airframe, fully avionics kitted, using a mouse only. That was quite an interesting exercise, I have to say. Royal Naval Weapons Trainer, close range weapons trainer. Low visual fidelity. We kept it quite low because of the distance and the dynamics of what was going on, but we used inert weapons. The Royal Navy wanted to use an Xbox controller, but the whole point of this training was these guys have to slew the weapons using their own physical body. So why not use the inert weapons, of which there were plenty? Use a head-mount display, the ProVision ProView XL50, and then that was able to, you were able to see your eyes, your eyes were able to see your arms and your hands and interact with the actual kit. So it wasn't a complete face tracking solution. And then finally, for example, the minigun desktop tray, which was a concept, through observations, we noticed that there was a slight lag between pressing the fire button, at which point the young trainees, and some of them were very young, were losing attention, and the gun had fired before they were able to take control of it. So it was more to do with the, I suppose, if you want to call it haptics, you can, but the vibration and the delay in firing was as important as the graphics imagery itself. And in this case, I think we were using the original CryEngine for that back in 2007. Helicopter rear door voice marshalling. Again, the whole idea behind this was to develop a simulator where we used mixed reality, a simple wooden mock-up of the helicopter, which enhanced the individual's movement training, or movement patterns within the confines of the helicopter, but we're also able to hold on to handholds in their accurate position. So very much a safety-based demonstrator as well as a virtual reality one. The graphics were very simple. They didn't have to be completely like the real terrain. We were fostering their attention to cues, to depth and distance, to vocally guide a helicopter down, particularly in close range. Subsafe, again, the demand here, no VR headsets. We want to train multiple training spatial awareness of a nuclear submarine. So what we found experimentally, and with Subsafe, we actually used 113 naval ratings in a series of virtual versus real trials at Devonport Dockyard in the southwest. And we found that passive presentation, where the students sit in front of an instructor, take them through the submarine, was as effective or no less effective than giving them a hands-on capability using a simple sort of gaming environment, WASD keys, mouse and screen. And finally, the distressed submarine rendezvous and docking. This was an exciting one because it meant we had to dive on a submersible off the Isle of Arran and to be able to watch what the pilot was doing and how that pilot was planning his approach to an underwater target, and then developing a simulator or a virtual reality tool where we provided the same kind of external views as he had on board, but made sure that there was nothing else cluttering his view. We were not designing this to train docking. We were designing this to train planning to approach the submarine prior to them going into the water. And then finally, we've got the Cutlass bomb disposal trainer. This is really quite a difficult one because the console and the robot had already been developed. And the console was one of the most ergonomic atrocities that I've ever come across in my life. It was a horrendous user interface, so we had no choice but to replicate it. But we couldn't replicate it using the mill standard controls because we would have priced ourselves out of the market. So what we did was we had to prioritize the controls and then build them into a small console, and then use that for mobile training and for manipulation training. It was reasonably successful. We managed to develop actually 42 simulators of these, which went out across the world: Cyprus, Gibraltar, Northern Ireland, and elsewhere. And then finally, medical emergency response team trainer. This is our main project at the moment. And again, all of the above basically. We're coming up to phase 3, where we're carrying out a series of both performance and cognitive evaluations of what's going on. We're using eye tracking, which we've already tested, pupil diameter for workload assessment, and we're hoping to get our hands on a new cortisol sensing device to monitor workload and stress in the individual trainees. You can also see there our approach to developing the console, the instructors terminal, because we want, as Niall was saying, we want to put all this together for a reasonable after-action review, and also for the instructor to be able to throw in curveballs to see how the small team trainees actually respond to situations that may be out of their control. I'll say all of this. I'm hopefully going to be rewriting this over the next few months to include some of these new findings, these new case studies. But people always talk about standards in virtual reality, and to me there is only one. There's only one standard, and this is it. ISO 9241, Part 210. Lovely thin document. Won't go into this in great detail because we haven't got that much time, but it's all about being able to understand the context of use and specify the user requirements, their target audience description, their knowledge, their skills, their abilities, and their attitudes. And how do we do that? It's very, very simple. There are a lot of academic tools and techniques for doing this, but my preference is to get out there and do it. So my view is to get out there, get involved with the end users, do what they do, go up in the helicopters, go down in the submarines, talk to them, watch what they're doing, listen to their training complaints, listen to their concerns, and build that around what the simulator should end up doing. And that's by doing that, by going out and taking that part of this ISO 9241 standard, enables us to prescribe the task fidelity. Should we concentrate on engineering fidelity, reality, psychological fidelity? Does it need to be virtual, physical, or mixed? Interactive fidelity, both display and input. Does it need a head-mounted display? Can we get away with a standard, decent quality 4K screen? Does it need to be wearable? Does it need to be conventional? And also in terms of context fidelity, don't just consider the task, consider what's happening around the trainee and how that impacts positively or negatively on their particular task performance. That could be environmental, it could be other team members. And that served us in great stead ever since. And the conclusions recently, in addition to what we did in the 1990s, are these. Virtual reality is not on its own going to change everything. Virtual reality is one piece of a large toolkit that really can help solve a lot of training problems, but not every training problem. We spend a lot of time protecting our potential adopters from online trade show hype, false promises. It's the same now as it was in the 1990s. It doesn't seem to be being suppressed. There are an awful lot of claims out there about what this technology can do, and we've still got a long way to go before there's some really, really good technological solutions. Concept demonstrators, absolutely indisputable, to help de-risk technology adoption. So, for example, carry out a small technology demonstrator, and then if the company likes what they see, if the demonstrator was reasonable, then go on to the mainstream project. Solutions must be future-proofed. If you're using a specific headset now and a specific glove or specific interactive technology now, make sure that when it changes, when that company goes belly up, you can still use new technologies next year. Technology agnosticism. Don't get wowed by technology, content first. And of course, do not ignore the importance of human factors and human-centered design. But we still see this. Every day I turn on LinkedIn, every time I turn on the internet, I see this. It does make me think, and for those of you who've never read Donald Norman's The Design of Everyday Things, this is mandatory reading for our students. And he puts out this little diagram here, which shows how we process information from the environment, how we formulate the goals and the cognitive aspects of making decisions, and then how we interact on the environment itself. But I do wonder sometimes, have the people who tout these things, have they actually, and for training and other applications, have they actually thought about the consequences the devices can have if they actually act as barriers between the world, be it real, be it virtual, and on their actual performance? Will it cause errors? Will it increase performance time? Will it result in will these barriers result in negative transfer training from the virtual to the real? Skill fade. What about skill fade? And finally, will it compromise situational awareness in terms of the goals that are being formulated for action? So we're still quite a long way away, I think, from being able to stand up and profess that virtual reality technology is mature. Yes, it is now, but that VR is now capture really needs to be taken very, very cautiously to make sure that what we deliver is actually fit for purpose. One day, not today, but one day, we may actually get it right. Thank you very much.
Thank you, Bob. Thank you for your presentation. I guess I have one question. I think the rest of the panelists, we can join us today. Just turn on your cameras. Niall, let's see if we can make it as well. David, well, nice to meet you. Glad to have you aboard in this Q&A panel. I have one question. It was, I think, for the panelists before, but I think it goes perfect for you, Bob, initially, which is because you mentioned this about, virtual reality is not for everything. And here is one question: where there are any aspect of current training that VR couldn't do effectively, okay? And actually, Christopher mentioned something before in his, presentation, I guess Niall as well. So maybe you can start with this one, because it's, where you should do, or where virtual reality really adds value to the training process.
I think we found particularly the medical emergency response team trainer, that there are, having conducted the observations with the RAF, and we've done it with the Royal Marines and the Army as well, we can actually tease out those elements of the training task which virtual reality cannot do very well, or if we was to do very well, would increase the expense of the project tenfold. So for example, because we're using a blue screen enclosure and we're using a pass-through camera, not the Vario XR3, but a pass-through camera, what we're finding is that there's certain elements of medical equipment that it would take ages to program and build properly, introduce the physics. So the beauty of doing that, and of course the same is true with the mannequin, we want to see that. You probably saw my hands. I can see my real hands touching the real mannequin, and to be able to carry out a surgical intervention without the use of haptic feedback gloves, because they simply wouldn't work. So I think it is important to identify, when you're carrying out a project, what virtual reality does well. And virtual reality does contexts, like the Chinook helicopter and what have you, and explosion effects and what have you, does that exceptionally well. But there are certain fine elements of the task, even when you're in a so-called high resolution headset, so-called, that it's still not capable of doing at all well. And that's what we need to do, this blend between the real and the virtual.
Okay, thank you very much. I would like to say something about this, because actually in both presentation we saw something about that mixed reality concept of having real haptic feedback, having that real event, the real element. In your case, you have that refueling mask, and you're in the virtual reality space, and we are moving fuel. You're also like touching that real, let's say, refueling mask. So where do you see that VR is, giving you value for training, in this case, for, full movement or for the process that you are involved in?
It's a great question. My first job when I was introduced to this, and I got to travel to Basque Country, which was wonderful, was to evaluate what this is going to work for, and what we shouldn't use it for, and where are the real benefits. And Professor Stone, I think your presentation was spot on. That's exactly what I found. I said, this is great for it. It's not gonna fix the hands-on, how to operate a torque wrench, how to assemble components, how to do things like that. It's going to give us, coordination, communication, how the team interacts, those kinds of things. That's where the value is. And so, we had to draw the line. We had a lot of people in our group that, they wanted this mask to be perfect. They wanted it just like what they're used to, and they're talking about, make it do all these things, and you have to sit there and say, hey, here's what we're focused on this. Here's what would be nice to do. It would be fun. It would be neat, but it's not going to meet our core goals. It's not going to meet what we need to do, and that's really what we focused on, and we kind of reined that side in and said, here's the goal of this. And I think that Niall's presentation was outstanding as well, because being able to certify people based on this, the first thing you need to do is you need to have credibility with what you're putting out there. And there was a question on how does the San Jose training compare to this training? And unfortunately, I can't answer that for you right now, because we're just implementing this, and we've just got it in. But I'd be glad to follow up on that at a later time. And really, that's what we're looking for, is to be able to use this as, maybe not the primary certification tool, but definitely as part of the certification, for these people to go out and work in something. But we need to understand what this does well, and focus on that. I think I answered the question.
Sure. Niall, would you like to add something else?
Yeah, like maybe even just to double down on, like I actually made some notes in Christopher's presentation on exactly this, and I thought he summed it up quite well, where like what it is really good for is like sort of those dynamic scenarios that are difficult to reproduce in the real world. I think Bob was talking about like smoke and that sort of stuff. Like we're doing a project at the moment with offshore wind, and like it's quite hard to reproduce the experience of being in a fire in an offshore wind turbine in the real world. Like it's impossible to do it without huge expense. And so those are the kind of situations there that simulation training works really well in. And then the other point Christopher made about that torque wrench, like torque wrenches are cheap. So if you need to learn how to use a torque wrench, just buy a torque wrench. So like that's the challenge, you know, like it's always like finding the right tool for the right piece of training. And like, so for me, VR it fits into a blended learning experience. It's not going to be the solution to every problem. And so, yeah, it's just maybe doubling down on what everyone else has said so far.
Agree. Don't know, David, would like to add something? If not, I have, and this is a great question, because I think that during this, pandemic situation that we have suffered, we've seen like a boost in the implementation, or at least, asking about, the potential of immersive technologies for training, design review, or other proposals. This kind of, you weren't able to travel, you weren't able to go anywhere. That remote collaboration, how I, train my workforce, they couldn't go to my physical location to be trained. So as the pandemic has a positive impact in VR and immersive technologies, I would say yes, but David, maybe you can answer this question as well.
Sure. Hi everybody. I'm the president of the VRAR Association in the UK, and work with you a little bit, David. So I guess just to respond on the previous one, I agree with everything everyone said. It's really about incremental gains. For me, it's just reading about additional retention of information working in VR versus, for example, e-classrooms and or even in person. So there are proof points that you retain more information throughout VR training. So I mean, that's definitely something that works well. And then the economies, the ROI positiveness of not having to fly people around and whatnot. So it's just about that versus being more realistic, being able to see the smoke or feel the heat or whatnot. But I guess that's where it works well. And just to add the mixed reality component, because I'm also very much focused on augmented reality. So I think when it becomes really interesting is when you can mix VR with AR and get into the mixed reality. So just using shared presence, I would say, where someone else from somewhere around the world, so using a healthcare example, when you have a surgeon in London and you have a colleague of his in LA that can connect and see what that surgeon's seeing, sort of give real-time recommendations and guidance, that becomes extremely powerful. And it's not something that we can necessarily do without the technology. So that becomes really interesting, yeah. In terms of, yeah, go ahead. I mean, in terms of COVID, yes, for sure. I mean, I work with a lot of startups and businesses in VR. I think just from an investment point of view, we've seen increased investment in VR companies like Verti in the UK, which is Oxford-based. They received a large amount of investment recently. Also VR, I mean, there's a lot of examples of companies that have raised a lot of money recently, and I didn't see that interest from the investment community globally as much before, I would say. So that's a positive spin on COVID and sort of getting accrued invests from venture capital and other types of companies going to VR. It does remain very much gaming focused, so it's a bit of a double edge, I guess, because VR's been, born out of gaming, and Oculus and Facebook are still very sort of dominant in terms of press and people talking about VR. I think most consumers will associate it to consumer grade VR and gaming, not so much enterprise VR, even though there's a thriving ecosystem on the enterprise side. So I think gaming is definitely growing, but it's helping build awareness on VR itself and the use of that for enterprise. So one interesting thing, for example, one company I work with, Body Swaps, who do training for sort of soft skills, are thinking about how they can get into consumer as well, even though they're B2B and their main clients are corporates and education. How can they also get onto Oculus? How can they also develop an app potentially that can be used by consumers? So it's thinking about piggybacking on that growth of awareness with the consumers around VR technology and training, and how that can apply to consumers. For example, how can you use it for interviewing skills or fighting phobias or other types of things that you can use VR for in terms of consumers? So that's been super interesting, I think, in getting more awareness to it.
Well, thank you, David. Awesome answer for all the questions that we I was asking you. And actually, Bob, do you feel the same in regards of this pandemic situation? You have a long track here in the immersive environment. Do you feel that this pandemic situation has boost at least the awareness of these technologies, not only for gaming, for the in the enterprise sector? That's why we're having this webinar today.
Yeah, I mean, the gaming sector, I believe, was responsible for resurrecting the fortunes of virtual reality back in the early 2000s. As soon as we started seeing things like the Unreal Engine and Half-Life and what have you, stimulating the games hardware developers to produce new graphics processing units, then virtual reality came back into its own. In terms of the pandemic, yeah, I mean, we've seen a lot of talk, haven't we, about the metaverse, this wonderful metaverse where apparently we're all going to be inhabiting Borg-like, and I cannot warm to some of the online platforms of people meeting in conferences. I long for the day when we can go to conference and events and meet up and network in the bar afterwards. I really find, from what little I've seen, it has been little because I didn't want to do it anymore, is I cannot focus on key messages because I'm confronted with a lot of very strangely clad, dismembered avatars who are flitting around doing silly dances with their hands in, and that to me is the distraction of that really turns me off. However, there's no doubt. I mean, as you said in the outset, I'm getting old. A lot of my kids and grandkids are involved with things like Engage and Verbella and all that lot. And I do think that there are particularly healthcare, particularly care of the aged, particularly things like relaxation and other, what I would call low-level, non-surgical healthcare aspects. I think that area is going to really rocket for virtual reality. That will come out of this pandemic in terms of making sure that people aren't lonely, making sure you can deliver quite life-changing, quite life improving events and systems to them. And I hope that happens. I hope that happens. I hope it's not all going to go enterprise, because that's another word I hate. Enterprise is just one of those words which is an excuse for adding zeros onto the end of your price, and that's why we've seen a lot of technologies not being put into the hands of the consumers recently. But yeah, let's say I'm an old, what do I know? But my kids seem to think it's coming. Yeah.
Well, thank you, Bob. I guess, Chris, because your project was cooked in this pandemic situation, how do you feel that, in your case, this is going to be one of the questions that, how do you feel this pandemic situation has boosted in GE Hitachi Nuclear Energy company, the usage of these VR technologies? And the second one, and this is going to be open for the rest of the panelists, lessons learned. Okay, maybe you can talk about the onboarding part of VR inside your company, for instance, and maybe, the rest of the panelists could talk about, from your perspective, Niall, as a vendor, that onboarding, with different companies that are working with, David the same, and let's see if, Bob, you have something to say as well. So, Christopher.
No, I thank you very much. So yes, most of the development of this project was done during the pandemic. It started a little bit before that, but going through and some of the challenges were, we got all the equipment to do the room, and Virtualware was supposed to come and actually install the room, and we were sitting there, well, we can't travel, we can't do this. And I've got a chief executive officer who says, I want this thing working. I spent money on it. And we were able to, using the tools that we have, transfer the knowledge, work with them live online and get the thing working. What we haven't been able to do is have a finished product and put that into our mainstream training right now. However, it would have helped because we have a lot of local people that we were having difficulty traveling, that would have been able to come to Wilmington to build proficiency, do things like that in an environment that was safe, where we can maintain social distancing and things like that. So I think, I can't really give you an answer on how it would affect us, because we were still in that transition during that. But I think that going back and looking at the lessons learned, we had people in our business who were over here saying, hey, that's not how we do stuff. And there were people saying, we need to do this for everything. And sitting there trying to find that middle ground in moving people, change management's difficult. And this is a very important change if you're looking to implement this. And the best thing you can do is just like the other presenters have said, make sure you're using the right tool for the job, make sure you understand what you're trying to accomplish, and make sure that you rein in the extraneous things that are going to be detrimental to what you're doing. You know, that's really the key to this is, you know, it's not the right tool for everything, but it is a very, very good tool for some things. And you know, Niall put it together, hey, things that are dangerous, things that are hard to reproduce, and things that are rare, you know, that's where this works. And if what you're trying to do falls into that, you know, mountain climbing would be difficult to simulate in VR and be effective, you know, because it's a tactile, hands-on, you know, kind of thing. However, you know, what we do, being able to incorporate physical mock-ups into virtual reality has worked very, very well.
I guess
So,
focus on the purpose. I think the last slide
Yep.
of Bob, just focus on the purpose, focus on the goal. Actually, we have a question here about, you know, when, you know, people focus more on the technology than on the purpose of using that technology. And that's the problem. Later we can move to that question, but maybe Niall, you would like to add something to this
Yeah,
one?
just on the pandemic stuff, like maybe I'll just, as you said, purpose. Like for me, the first question we always ask on any project is what problem are we trying to solve? I think Bob made that point really well, like actually getting out into the field and seeing, like we talk a lot about authenticity of training. So like it's not about reality really, it's what's the most authentic way to deliver the training. Is it like just on a computer screen, or is it like that you actually hold the wrench, or, you know, like I've actually like pushed people away from VR because it's just not the right approach, and kind of know that we're just opening ourselves up to a project that's actually not going to solve the problem for the customer. So that's the first question we always ask. But maybe to go back to the pandemic stuff, like early days in the pandemic, it felt for us like this is great. Like it, you know, people are really seeing the value of remote working and remote training, and like, you know, at a basic level, like we're busier now than we've ever been. But like I'd sort of say like it's probably a mixed bag is kind of where we're at the moment. Like definitely like stuff like Christopher was talking about, like this idea of travel to train, I think is probably going to increasingly be less popular. So like you have to travel across the world to spend a week in a training center, where you can sort of be sent a headset or a computer where you can train at home, or that like 4 colleagues can all train together in one virtual world. Like increasingly I see that as something that's going to be fast forwarded by the pandemic. I guess on the other side of things, so like from a practical perspective, like we're finding challenges at the moment with like the full remote workforce and actually testing the experiences. So like, you know, we've done sort of virtual presentations where, you know, we sit and we put on the headsets and we sort of talk through it. But like we've also just started to get people back into the office where like having 4 people sitting around and you all sort of like one person puts on the headset and then you have a conversation around like, well, this worked well and that thing over there, and stop it there. And like it just doesn't compare. Like it like we're finding we get through stuff like testing much quicker when we can do it co-located. And then maybe the final point I make around the pandemic is, and I think it's talking about the popularity of it. Like we were getting to the point with sort of the sales process that we were getting calls from people saying like, you know, I tried VR in my brother-in-law's house and I've had this idea of how that applies to my business. When people can't visit their brother-in-law's house, you're kind of reliant on them buying the headset and testing themselves. So like, again, it's kind of a mixed bag, you know, like it really, and I think someone put the message in the chat there, like the best way to experience VR is actually to put on the headset and actually go and do it. Like you can't show videos about it. Like one of the only quotes I remember from college, I think it's Elvis Costello, was like, writing about music is like dancing about architecture. And so it's kind of the same with VR. Like you can talk about it, you can show videos of it, you can do presentations, but until you're actually in the headset experiencing what it's like, you really can't appreciate the way it works. So again, that's probably the flip side of the pandemic, is it's much harder to do that.
Well, thank you, Niall. More lessons learned in this pandemic situation. Bob, just lessons learned from your perspective. I think you share something, you know, on your slides, but maybe you can just summarize 1 or 2 of them.
Oh, good grief. Well, I mean, the obvious lesson learned that I found in across the 3+ decades, it's about putting the user first. It's not just a case. There used to be this thing in the 1990s where they said, well, if you put on your virtual reality headset and you put on your data glove, your VPL iPhone 2, your data glove Model 1, all the interface problems of the world would be solved. You know, by the end of the 20th century, we were all going to be shopping We were going to be going to supermarkets. We were going to be picking up bread. We were going to be squeezing it. We were going to be smelling it. And guess what? It never happened. And it's not surprising really. So lesson one, yeah, human factors. It's what it's all about. Technology second, maybe even lower down the scale. Put the human first. That's the only lesson learned, apart from that list of lessons learned that I gave you a little bit prior to this.
And that's why sometimes we lose, the point. That is the user. That's the main point. And then we focus more on the technology. And actually, the question I asked you before, and I want to come back again, it's like when people get too excited about using VR, that maybe they lose the focus on the simulation. What would you recommend to avoid this? That's one of the questions. I mean, then you can have people, okay, VR, instead of focusing on this is the purpose, because maybe VR is not the technology. Maybe it's all the technology. And
absolutely.
In my case, we found in some meetings that we had customers or potential customers just saying, I would like to do this with this technology. And we say, that's not possible. This technology is better for your use case. So the purpose first and the user first as well. So Bob, maybe you can step up with this one.
Yeah, Niall's already said it. And I think in terms of, we've turned people away. Excuse me. One of the funniest examples was that the Royal Navy came to us, but they were closing down the submarine escape tank trainer, which is a really huge vertical water tank that they train guys and gals nowadays to escape from submarines. So you have to put on your suit and you have to go up through this huge tunnel of water, and there are divers there pushing on your chest to make sure you breathe out all the way. And they came to us and they said, well, we're closing this down. And we're closing it down because of health and safety reasons. Well, okay, health and safety, trying to get out of a distressed submarine. What's the logic in that? God knows. Anyway, that's the way the Ministry of Defence does things on occasion. Replace it using virtual reality. Come on, you are joking. I mean, yes, of course we maybe use a headset and go through the process of configuring the hatch and undoing the hatch, but then the water pours in on you, and you feel the pressure on you, and there weren't any suits then. There aren't any suits now that will actually give you that same effect of going up and having to breathe out. And occasionally you get those. And they say Niall's had exactly the same experience. People come to you because they think this stuff can do everything. And the best way around it is to have a portfolio of projects and get them to try it and say, look, this is what we did for X, this is what we did for Y. Try it. Now come into the conference room and let's discuss what you really need.
Okay, thank you. David, maybe you would like to jump on with this one?
I mean, I guess I just wanted to point out also the cost for a client to engage a company for VR. I guess there's the various different solutions. I mean, some cool companies are now coming up with off-the-shelf solutions for VR training. So I guess one big question for me is how much customization is needed by that client, for example, when and of course maybe a lot of customization, but hopefully the more experiences are built for enterprise, the more some of these can be reusable, and then the cost will go down, because that is a big factor, right? For companies that might not have the budget. A lot of the budgets are coming for innovation buckets rather than mainstream buckets for a company. So some companies are coming up with off-the-shelf, which means it's going to be more affordable, but then it's not going to be as customized, whereas the customization is going to be a lot more expensive. So that becomes really interesting to me. And then lessons learned is also probably around, I would say, case studies and insights that come out of the results. And just, the proof is in the pudding, as we say in England. So just proving that this is actually efficient. So there's a PwC report where I got this sort of retention increasing with VR training versus classroom and whatnot. But the more case studies we have and the more of these metrics we can show, the better also for companies to start adopting the technology, and again, making it more affordable. But then in terms of steps, I didn't see a lot of presentations, but I would say for sure, you need to train the trainer. I think a lot of companies assume that you just grab headsets and it's easy to use. Oftentimes internally you have to assign teams, you need to train them up. So the company that produces the content will probably need to train those people. As the colleague said, do you do it in person or not? How do they clean the headsets? Of course, with COVID, there's been a lot of questions about that. And some companies have provided, like Cleanbox, have provided boxes or technologies to clean those headsets, for example, as short a time as possible, because the other thing is you lose a lot of time having to clean them up and send them to other people, etc. So there's a lot of considerations there. Yeah.
I think you touched one point, which is that the return of investment, okay, the cost. And sometimes, if you focus on the purpose and maybe from the very beginning, you have that business case, more or less what you expect. And then you have that written down and then you have, okay, this is going to be the cost, because actually we have some questions about the costs of different use cases that the audience have seen. And then you put that down and then, okay, what you are reducing in this case of traveling or whatever, then you find if this is, expensive or if not. Sometimes it's more about, the risk about, moving from this technology, from the old one that you were previously using. We are running out of time, but I want to give you, each of you, just 1 minute, to summarize any of the points you would like to, and then we will close this amazing webinar. So let's start by how we've done this webinar. Christopher, you go first with your final statement.
No, actually, I thought all the presentations were great, and I thought you had a variety of presenters on a variety of topics. Mine was very specific. Niles gave a great background, and Professor Stone's was outstanding as far as different things that I never really thought of this being used for. So I appreciate the opportunity to come here and speak. I appreciate everybody's participation, and I learned something as well. So thank you very much.
Thank you, Chris. Global Training Manager of GE Hitachi Nuclear Energy. Niall, please go ahead. Your final statement.
Yeah, final statement / maybe lessons learned. I'll try and combine the two. And what I would basically say is what I'm going to do and what I would recommend everyone does is take Bob's final slide around his lessons learned, print it out and hang it on your wall. I think that's it's a good summary of the mistakes that people have made and lessons that you can learn from how not to do things. And I think that's a great sort of example of sort of a synopsis of sort of years of experience. And because that's the challenge a lot of the time. It's we're a young company, we're only 4 or 5 years old. Looking back and thinking about this is an industry that goes back to 100 years and thinking about lessons that have been learned as it has developed. Maybe from a practical point of view, I would say don't let developers play with buttons on controllers. I find the biggest user experience problem we have is people who are used to playing games design an experience with all these buttons, and then they hand it to a mechanic or a non-technical person who's not used to playing games, and they just can't pick stuff up, and you just lose them straight away. So probably, again, echoing Bob's point around user experience and testing stuff as you go all the way through. And then maybe the final point I'd say is around the idea of proof of concept to sort of a deployable product and having a roadmap. So thinking about, once we've done this proof of concept, well, how are we going to roll it out across the organization is really important for me from a sort of, deployable training perspective, and just thinking about that when people are starting to look at proof of concept projects, think about, well, how are we going to scale this across the organization, not just develop this one sort of standalone VR experience.
Agree.
And then maybe finally, thanks for having me, and great to be involved with such a prestigious panel.
Well, thank you, Niall. And I agree. It's think big, start small, and scale fast. That could be, the concept is just one sentence. Thank you, Niall. Bob.
Yeah, what a great webinar. I mean, it's wonderful to sit here, and I sat through Chris and Niall's, and I suddenly thought, well, there's an awful lot of synergy between what we've been talking about, turning people away, focusing on the task, using mixed reality, using real-world elements to enhance the believability of the virtual, which Chris was talking about. Absolutely fantastic. I still put out a plea. I mean, I wasn't that impressed with the PwC report, because we are in a community that is desperately in need of gold standard in terms of looking at human performance, looking at ROI and various other things. And I'm afraid there are quite a few criticisms of that report, which means I tend not to use it. But I suppose the parting message will be, and I think in terms of, oh yeah, but I love your buttons example, Niall, because it's one of the reasons why. But it's true. It's one of the reasons why the RAF said to us, no headsets, no gloves, no keyboard, all those years ago, because they didn't want people going in and writing macros. So that gave us a challenge. But just to end up and shut up, I go back 1987 when the two guys that Steve Ellis and Scott Fisher snuck me into the labs at NASA, put me on this headset, put me on a virtual escalator, changed my career, and I got wowed by the technology. But those guys were doing human factors experiments about how much information you could put in front of a human when they were trying to control a tele-robot outside the International Space Station. And they were looking into human factors then, and we're looking into human factors now in exactly the same way. And I think, again, it's just testament to the fact that it's not an expensive thing to do to get a human factors person involved. It really is not. And a human factors person worth their weight, and they're much younger people than me, can do all these things and really add value to your project. And so hopefully that's, if people take away that message, we'll have all done our job.
Thank you, Bob. I'm running out of batteries. I don't know if I'm going to, my PC is going to go off. So David, your final statement, please.
Thanks. Just to thank my colleagues who have done a lot of the hard work and presented when I'm just joined for the panel. So a lot of respect for your presentations. Just on I shared the link to the PwC report. I mean, I agree with you, Bob, and it's mainly focused on soft skills training rather than full simulation anyway. But for me, any case study, any insights coming out is always helpful. I mean, on my side, just working across mixed reality, not just VR, I would just say how excited I am. Also, thank again all the pioneers that have been working on VR technology, as you said, Bob, for such a long time and paved the way for others. I've just started 3 years ago, so really owe it to a lot of those pioneers and people who have worked through the valleys and everything else. But if we're still live, I'm not sure. Just to say that I'm really excited about the future. And as I said, there's a lot of investments coming in, but also thinking about mixed reality and the headsets that are coming out in the next few years are both VR and AR. Just want to remind that a lot of us consider sort of VR, AR as the next iteration of the internet, as the Web 3.0, what we call spatial computing, which for me is a game changer for any interaction that we'll have in the future. So beyond enterprise and training and simulation, I do believe in the next few years that it's going to be changing smart cities and the way we shop, the way we navigate through tourism and other sorts of applications. So it is a very, very important change in technology, a revolution, I would say, at this stage. And so all the examples we've seen today are proof that this is happening. And thanks for having me.
Okay, thank you. And as a wrap up, I really appreciate your time. I know that these are difficult times, even to have this kind of discussion that really add value to the audience. So thank you to Bob, Niall, Christopher, David for joining us today. Thank you to all the audience for being here. We had almost 150 people live in some parts of this webinar, so that's great. And about like 500 people on the LinkedIn event registered. So thank you all. Here's my contact as well. And just to end this, we would welcome you to be part of the European Training and Simulation Association. We are part of this. We are trying to grow this modeling, simulation, and training community here in Europe. So we encourage you just to take a look to the website. And if you think that these kind of discussions are worth it, you should join us. So thank you, everybody. Thank you for being here. Next week, we'll share the recordings with to all of you if you have sent your emails. If not, I will try to reach out to all of you through LinkedIn at least, so I can get your emails to send off the recordings to you. So thank you, everybody. Nice to meet you all, and stay safe and enjoy summertime.